shouldn't I, if I wanted it? Okay. Yeah. All right, so let's get back to an area, because we're going to share some responses out. So if you guys would find a spot with your partner, we're going to look at some people's solutions to think about what we know about multiplication of whole numbers and how it's connected with fractions. Remember, that's what we're learning today. So let's take a look. During this time when we're sharing, hands are off the manipulatives, pencils are down, and we're going to listen to our friends share. Okay, so I want you to look at this first model. Is it Eva? Just return her group back here. So I'm going to put this, and then remember, Miss Lowe's is technologically challenged. So I'm going to put it right there. I want you to take a look at what they have there. Everybody take a look at Eva and her partner, the patient? Kayla's model. Y'all see that? Yeah. So I want you to think about this for a second. What are they modeling here? Think, don't yell it out, just thinking. Remember, hands off your manipulatives, pencils are down, everybody's just looking. And is this like something that you did? Thinking about, is this what we did? So I need you to look and think about this. Remember, we were learning the connection between multiplication of fractions and whole numbers? So the number of groups and number in each, what they have modeled there. I want you to turn and talk to your neighbor. What are they showing? Are they showing the number of groups? If so, what is the number of groups and how do they know it? And the size of the groups, are they showing that? So turn and talk. What do you see up here? Talk to your neighbor.
There's 2
Alright, so come back up and let's share some thoughts here that Eva and Kayla. I had a Kaylee earlier, right? Okay, so let's take a look here. So I heard some talking out there. Tell me what you see. Where do you see groups and where do you see the size of the group? Who wants to tell me what their partner talked about? Talk to me. Where are the groups?
The groups are like the blocks.
Oh, so y'all see that? Like this is a group?
No.
And this is a group?
No.
This is not group?
No.
Oh, they're saying no. What do you think? Is that what you're telling me though? Are you saying these are the groups? She's saying yes.
No.
So let's keep circling them. How many groups are there, honey?
8.
She's saying that these are 8 groups. A bunch of y'all are saying, no, those aren't the groups. She's saying, yes, they are the groups. Turn and talk to your neighbor. Why do you think she thinks these are the groups? Why do you think she thinks these are the groups?
Eight people have to bond. 8 people have
Alright, come back to me. So, tell me your name, sweetheart, again.
Kirsten.
Kirsten is saying these are the groups and there's 8 of them. What do you think? Where would she get that? What is she thinking? Where would she get that 8 from? Yeah.
If you multiply the quarters by 8, the 8 is your group.
Okay. He's saying that the 8 are the groups, but go back to the problem, y'all. We were solving a problem. What's the 8? The 8 people. How much is each person getting?
1/4.
1/4 or 1/4. So we have our number of groups. How many groups are there?
There's 8.
8, and this time groups happen to be people, right?
Yes.
8 was the number of groups. And what was the size of the group?
4.
Oh, a fourth, you're telling me. So I'm seeing this, that we have 8 groups of a fourth. Would you agree with that?
Yes. No.
So then how many pounds of hamburger do I need to buy? Do I go to the hamburger counter and I say, I need 8 1/4 pounds?
No.
No. What do I tell them?
2 holes.
2 holes, because how many fourths do I have here?
4.
Total of 8. 8 what?
8 groups of
8 groups of a fourth, but what size are my groups?
people.
1/4. What part of a denominator I told you the answer. What part of a fraction tells you the size of the group?
The
The denominator, that's right. So I know I need 8/4, which you all told me is also, this is a pound, and this was a pound, you said, so that was 2. So hang on a second. Here's another solution, though, that I want you to look at. So look at, oops, and I've written all over that, so let me make sure we can see it. If you want to erase that, that'd be beautiful. Not the equation, but the circles, please. If you could erase the circles, that'd be awesome. So I want you to take a look here at this equation for this problem. We'll keep that model up there. So look at this Kinley's, I think this is Kinley's group, right? Yes. And so Kinley they wrote this equation. Talk about what we know about multiplication to your partner. Why did they write that equation? Turn and talk. Why are they writing there?
If you convert it into like groups.
Let's turn it look. Alright, let's come back to this equation. Why do you think Kinley and her group wrote 1/4 plus 1/4 plus 1/4 plus 1/4? Why did they write all that? What did y'all talk about? Why did they write all of that? Yeah.
Because they wrote it 8 times because there's 8 people.
Oh, there's 8 people. Does that sound familiar from earlier?
Yes.
The people were the what?
Great.
The groups, right. So do we see her groups?
Yes.
What else do you know about multiplication and a bunch of addition? What do you know about that?
They're the same kind of.
Oh, what do you mean they're the same kind of? What does she mean by that? What do we call this when we add the same thing over and over and over?
Repeated
addition. So earlier when we had 6 times 3, we knew that that could be 6 plus 6 plus 6, right?
Yes.
Or 3 plus if we're doing that. So actually 6 groups of 3. I should have written a bunch of 3s 6 times if I'm reading my equation correctly. 6 groups of 3. So if we're looking at this, does she show 8 groups of a 4? Does she show 8 groups of 1/4?
Yes.
She does. Interesting. So I had one more equation that I wanted you all to look at. Let me see if I can find it now. I didn't grab it on my way up. Oh, you rearranged yours, didn't you? Can we talk about that? Can I talk about how you rearranged this? So Zach and his group, they had earlier written this. They wrote that. And Zach rearranged it. Turn and talk to your neighbor. Why do you think he rearranged this and he wrote instead of this, he wrote this? Why did he do that? So what does the first factor tell you? Tell your group, what does the first factor tell you?
And she said, well, and so your groups are 8.
I love this.
Your groups.
Okay, so come back and let's talk about Zach and his partners and why they went from this to this. What do you think Zach and his partners were thinking? Why would he change it to write it like this? What do you think?
Zachary knew he was wrong because 1/4 times 8, that's like, well, that's 8 fours.
Okay, keep going.
Then he saw Kelly's paper, then he knew he was wrong, so he put that. Then he
Can somebody help? Hang on a minute. Jacoby. Somebody help Jacoby's thought process out. What was he thinking? What do you think? What's he trying to say?
He's trying to say like that if you wrote it 1/4 times 8, that means you would have 8 1. No.
1/4 of 8, or if we're doing the groups of 8. Is that what the problem told us to do, to have the group size of a 4? I mean, the number of groups as a 4?
No.
No, what did the problem tell us?
To do 8 groups.
Oh, that there were 8 groups of a 4. Now, is he wrong? Is he going to get a different answer?
No.
No, because just like 2 times, or let me use this one, 3 times 6 and 6 times 3 are commutative, right? We're going to get the same answer, but we're talking about modeling what the problem said. The problem said we had 8 groups of a 4, and we didn't have a 1/4 of 8 or a 1/4 of groups of 8. Does that make sense? Okay, so we need that 8 groups there. So here's what I want you to turn it up before I show you this last solution, okay? Remember what we're doing today? I hope so, that we're connecting what we know about whole number multiplication to multiplying a whole number by a fraction. So how is it the same as how is this multiplication the same as this multiplication? Turn and talk to your neighbor. How's it the same?
It's the same thing, because if you flip the yeah, because if you flip the division like that one, it's messed up. If they say multiplication, but if it's division, it's the same.
Connection has been terminated. We're not going to touch it. We're going to pretend that doesn't say that. I don't want to touch anything. Miss Love just messed something up. Okay, so back to me. We were talking about how are they the same. So how is multiplication of our whole numbers like our multiplication of our fractions? What y'all talk about in your groups? How's it the same? What'd you talk about?
We said that if you flip 8 times 1/4, it'll get you the same thing. Or you can do 1/4 times 8.
Mm-hmm.
Because multiplication, you could flip.
Okay, so we said it's commutative, that you could get the same answer no matter what order. Would y'all agree with that?
Yes.
But what else did we notice is the same? Anybody notice anything else? Yep.
There's 4 8s.
There's 4.
8.
What do you, are you talking about here?
There's 4 8.
Yeah, but we'll look at that solution in just a second. But what do we know about multiplication of whole numbers and multiplication of a whole number and a fraction? What's the same? Let's turn and talk one more time. Here's what I want you to use. Use this language. Number of groups and number in each. Y'all with me?
Yes.
How is that the same for this problem and for this problem? How is it the same? Turn and talk. What did you know?
You like tap on or a mixed number.
Okay, so come back to me. Who wants to tell me what they're thinking here? Using the language of groups of. What was the same? What did you and your partner talk about? Using the language of groups of. What was the same in this problem and this problem? Yeah.
6 groups of 3 in each equals.
All right, 18. So he said in the whole number when we had 6 groups of 3. How's that like this one? We have what?
We have
8 groups, except the size of the group is
1/4.
1/4. So what's the connection here? Does it matter if you have fractions or whole numbers? No, if you're multiplying, you can make equal groups. And some of Kaylee's group, I think, showed us that we could do repeated addition, which, did I say the name wrong?
Yeah.
Or we could show that with multiplication or a model. So last thing I want you to look at to wrap up today, because remember, we're looking at this connection. So this was the second problem, where we had the guest eating a third a bag of chips. Look at this model here. Do you see this?
Yes.
See that model?
Yes.
Remember, what do we know about multiplication? It's the number of groups and the size of the group, or the number in each. I'm going to change that to size of as well, the group, because it's kind of the size of the group or the number in each group. So where